Summation and integral calculus. Okay, very fruitful discussion that we are pursuing, that is summation and integral calculus. How summation can be used to bring in integral calculus. I believe we are in midway of one exercise that we are doing. What is the value of summation? Summation, summation 1 equal to 1 to infinite. Sigma I equal to 1 to infinite. I believe that this is very straightforward. Summation sign I equal to 1 to infinite. 1 by 2 to the power I. So it will be 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus infinite. As we go toward the infinite, it will be tends to 0, 1. Okay, what is this summation? Summation I equal to 1 to n, and then summation I equal to 1 to n, where n tends to infinity. 1 by 2 whole to the power I. Okay, now anyone would jump on the solution. I can provide solution quickly. Consider that summation is s. S equal to 1 by 2. 1 by 2 plus 1 by 4 plus 1 by 8 and so on. Multiply s with the 1 by 2. Now I have 1 by 2s equal to 1 by 4 plus 1 by 8 and so on. Now subtract it. S minus 1 by 2 into s. It will be equal to 1 by 2. 1 by 2 s equal to 1 by 2 s equal to 1. Actually the summation will be 1. Can we try this through the can we try this through the integral calculus? Integral calculus is that how integral calculus means I have to transform this summation to integration. Okay, concept is we have this, there is no book written, at least I have seen, where it is so clear forward that how we can transform a repeated summation into integral. This example is also not there anyway. Okay, what solution I provided, this is the solution provided in the book. But can we try solving it through integral calculus? First of all, how I can, if I have a, what is 1 by 2 to the power I? Okay, what is 1 by 2 to the power I? Whatever it is, what I want. If I want to solve it as integration, why I want to solve it as an integration? Because n tends to infinity. Whenever I see in repeated summation, n tends to infinity, then it is candidate for the integral calculus. For the I, means what we are trying here is that if I have x-axis, if I have x-axis, this is origin, and this is going like this towards infinite. Okay, when I equal to 1, so now I divide this infinite into n part. Consider it is, this is x-axis and this is origin. If this is origin, then x-axis is going like this and up to n, up to n. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to n. And then I divide it into n part. This is what should be understood very clearly. We have x as 0 and x as n, and up to n I divide it into n part. Okay, I divide it into n part. Now for each part I have vertical. What is the vertical? For the first part, vertical is 1 by 2. Second part, vertical is 1 by 4. It can be considered as probability also. What is probability? Probability is nothing but the height what we are talking about at any moment, any point. What is your height? Height, if we see height and divide by the number of occurrence, number of sample in the sample space, that is called probability. Anyway, we will do the way it is. So in that fashion, we have, when we are in first section, I divided 0 to n into n part. Each part has a width of 1. When we are in first section, the height is 1 by 2. 1 by 2 to the power I. For ith section, it is 1 by 2 to the power I. In first section, it is 1 by 2. In second section, it is 1 by 4. In third section, it is 1 by 8. In fourth section, it is 1 by 16, 1 by 32, 1 by 64. It is reducing in that fashion. Okay, now I have to bring it summation I equal to 1 to n 1 by 2 to the power I into an equation called fx dx. X is 0 to what or 1 to what. Okay, rephrase this. Now what we have summation I equal to 1 to n, and then we have 1 by 2 to the power I. I can say a to the power I, where a is constant. 1 by 2 to the power I. I can say xi. Makes sense. 1 by 2 to the power x, where x belongs to ith section. Since I goes 1, 2, 3, 4, if length of this stick is 1, length of stick this 1, consider, and I chop into n part. Each part has a width of 1 by n. Ith section from, if I talk about ith section, then what is the x from origin to ith section? What is the distance? That is x. What is the distance? Then x is I by 1 by n into I. If I divide 0 to n into n part, and if I take ith section, what is the distance of the x? I. Okay, whatever it is. So I am renaming this summation now. What is summation now? The summation is summation I equal to 1 to n. Summation I equal to 1 to n. 1 by 2 to the power x of the ith section. Okay. Now, same thing. 1 by 2 to the power I, or 1 by 2 to the power x of the ith section. Okay. If that is the scenario, x of the ith section is a scenario, summation I equal to 1 to n, 1 by 2 to the power x of the ith section, if that is the scenario, how it can be converted into integral calculus. This is one step we have proceeded. What is next step? The next step is summation I equal to 1 to n. Can I consider is fx 1 by 2 to the power x, 1 by 2 to the power x, where x belongs to ith section. X is the distance from the origin. What is the x of the ith section? That has to be calculated, but it will come in this form. Summation I equal to 1 to n x to the power of 1 by 2 to the power x. X belongs to ith section. That is the distance. I believe it is all right. Okay. If that is the case, then can I say it is as summation I equal to 1 to n fx function over x, x at the in the ith section, function over x, x in the ith section. Now we have summation I equal to 1 to n fx. What is next term? Summation I equal to 1 to n, where n tends to infinity. But if n tends to infinity, the question is become again like, if this is x-axis and this is origin. If this is origin, then it goes towards infinity. Till infinity, we divide into infinity part. Okay, in that fashion. So I equal to 1 to infinity n, where n tends to infinity. Where n, I'm not dividing 0 to n into infinity part. N tends to infinity. N is at two places. One is 0 to n and then into n part. Both became infinity now. Summation I equal to 1 to n, where n tends to infinity. And then function over x, x belongs to the ith section. Can it be brought up? Can it be brought up into integral calculus? Because this is infinity, I cannot calculate it. Okay, let's move ahead now. If I want to bring into integral calculus, then it will come in a term of integration x equal to begin to end fx dx, or integration x begin from 0 to n, x begin from 0 to n. Makes sense? X begin from 0 to n. N tends to infinity. So x equal to 0 to infinity. Fx dx, gx dx, whatever it is. What is your fx dx, fx dx, fx dx? This is x-axis. and there is a perpendicular to it called function over x-axis. This is x-axis and this is function over x-axis. This is x-axis and this is function over x-axis. Makes sense? Okay. If that is the case, no, no, no. This is x-axis, this is y-axis. Both are same only. If this is x-axis, this is y-axis. Y-axis is function over x-axis only. If this is x-axis, this is function over x-axis. Okay. In that fashion, consider that there is function over x. Actual graph is there called function over x. What is your function over x? Function over x. Consider there is a graph called function over x. Hope I'm trying to get to the graph. Okay. Consider there is a graph called function over x. This is function over x. What is function over x? If I take any point in x and draw a vertical, it will go and hit this line. If I take any point here and draw a vertical, then it will go and hit this point. This height is function over x. At any point, this height is function over x. At any point, this height is function over x. Makes sense? So wherever it hits this line, that is function over x. That is function over x. Okay, if that is the situation, now we have repeated summation. Summation I equal to 1 to n tends to infinity, function over x where x belongs to the ith section. Means I cannot take randomly any point and say what is function over x. Okay, I know function over x is a line, but I have to take sampling on the x-axis at few points only. That is x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5. At 3 point only I have to take sample. I have to draw vertical, and whatever is the vertical is there, that I have to sum it. So what is function over x? Function over x is 1 by 2 to the power x. Makes sense? This is function over x. Up. It will be a straight line. Huh? I don't know. It is not. It will not. It will not be a straight line. Okay. It will be like this. Hope. Okay. It will be like this. At the beginning, it will be 1 by 2, then 1 by 4, 1 by 8, 1 by 16, 32. It will go like it will go to 0. Okay, but any x I cannot take. Okay, what is the value at 0.5? No, no, you cannot take 0.5. Either you have to take at 1, 2, 3, 4, because it is summation. Summation I equal to 1 to n, where n tends to infinity, function over x at x equal to I. Okay, how I can convert it into integral calculus? That is the question mark. What is integral calculus? Integral calculus, this is the form of summation. Summation has its own grammar, whereas integral calculus has its own grammar. Consider integral the what I am saying, summation I equal to 1 to n fxi equal to integration of x from 0 to infinite, because this is how we have taken gx dx, gx dx. These two are same. Okay, left side we have sigma sign summation. Sigma sign means summation. Summation I equal to 1 to n tends to infinity, function over x at x equal to I. This I want into integral calculus. This is the summation notation. Equal to x is 0 to infinite, gx, g is a function over x, g bracket x bracket close, gx dx. Now question is arising, what is gx? Okay, let's write it again. Summation I equal to 1 to n, where n tends to infinity, fxi. Can I write as fxi into 1? Anything I can write multiplied by 1. Okay, into 1. What is 1? Same result will come if I multiply by 1 and then sum it. Okay, what is 1? If this is x-axis, if this is x-axis and this is the graph of the fx, that is 1 by 2 to the power x. Now, if I take at any point, if I take at any point, here consider this point is alpha. Alpha can be 1, 2, 3, 4. Even, sorry, integer value. If I take alpha, any alpha, then if I go up, then it hits here. Okay, then multiplied by 1. 1 is the gap here. This is how I am interpreting. Anyone can interpret it. Fxi into 1, it looks like side of a rectangle, where one side is fx and bottom side, the width side is 1. So if I take I equal to alpha, alpha at any alpha, this is origin and this is x-axis. This is any point alpha. At alpha, fx at I equal to alpha, up. This will go up, this will go up and it will hit here. Okay, this height into 1, this is what we are saying. This will give a area of this strip. It will give area of this strip. Makes sense? It will give area of this strip. Okay, what is fx dx? Let's consider what is fx dx. If I consider this as fx and I say fx dx, that is the area underneath it. Fx dx is if this is x-axis and this is fx, fx dx is the exactly area underneath it, full area. From x beginning to x end, full area. But whereas we are saying fx into 1, summation fx into 1, where I'm saying 1 is the width and fx is the height. More or less, we are trying to calculate area of the one section, that is the ith section. If I add all the section like this, it is actually exactly fx dx. Okay, means we can proceed as integral calculus. Okay, now what is the next frame? Next frame is I equal to 1 to n, where n tends to infinity, fx of the ith section into delta xi, where delta xi is constant 1. Okay, if I have in this formula summation I equal to 1 to n tends to infinity, function over x belongs to ith section into delta xi of the ith section, what is the width, where I is in number, not in fraction. Fraction in a way that consider that I have a stick of length 1 and I divide into n parts. If I do, then each part has a width that is not 1 by 1. But if I have a summation and summation is I equal to n tends to infinity and I is in number, then fxi delta xi is the width of one section. Like that, if I add all the area of one section, if I add all the area, it becomes pure integration. Now we have integration x equal to 0 to infinity 1 by 2 to the power x dx. Same. Will the result will be same? We know the result. Result is 1 by, result is 1. Result is 1. This is what I remember. 1. Summation is 1. Will it come as 1 or near about it? But we don't want near about it. If it comes near about it, then why it is coming near about it? Why it is not coming as 1? Anyway, let's proceed. So, in that fashion, now we have in that fashion what we have now in our hand. Fx dx, x is 0 to infinite. I believe it is all right. X is 0 to infinite. What is fx? 1 by 2 to the power x. What is integration of 1 by 2 to the power x? What is integration of a to the power x? What is integration of a to the power x? Okay, someone can try. What is what is integration of e to the power x? E to the power x. What is integration of e to the power x? E to the power x only. Let's consider integration of a to the power x is a to the power x only. If that is the case, then differentiation of a to the power x will be a to the power x only. Okay. Now let's consider I have a to the power x equal to y equal to a to the power x. dy equal to d of a to the power x, or dy by dx. dy by dx equal to d of a to the power x by dx, and it should come as a to the power x. Okay, so dy by dx equal to d of a to the power x by dx. What is differentiation of a to the power x. Okay, that differentiation is nothing but dy, that is nothing but dy. In shortcut, we can write dy equal to d of a to the power x. We want dy. The answer is we want dy. Anyway, if y equal to a to the power x, then logarithmic of y equal to x. Make sense? If y equal to a to the power x, then I'm sorry, y equal to, then log of y, I'm changing the base. The log of y equal to x, where log is a base of a. If y equal to e to the power x, then log of base e of y equal to x. Here log of base a to the power x, y equal to x. What is log of a? Log of y to the power base a. It is same as natural log, that is logarithmic of base e. Natural log ln y by ln a. Make sense? Logarithmic of y with a base a. It is same as ln y by ln a. Okay, then ln y equal to ln a into x. Okay, now we will calculate the derivative. Derivative of ln y is 1 by y, 1 by 1 by y dy equal to ln of a. Ln of a I can keep outside. Ln differentiation of a to the power x. Okay, means, I'm sorry, right side we have ln into x. If I do derivative with the x, it will become ln a only. X will go away. Now we have dy by y equal to ln a. Dy equal to ln a into y. Y is a to the power x. Means dy we want. Means differentiation of a to the power x equal to ln a to the power x. If differentiation of a to the power x is ln natural log of a into a to the power x, then integration of a to the power x is a to the power x by ln a. Simple. Okay, so I did this so that people should understand that it's not very difficult to calculate the integration. People can go other methodology also. No one is stopping anyone. Integration of kind of we can try by part or something like that. Someone can try. I don't know. Okay, whatever it is. This is how, this is how it is. Anyway, so integration of a to the power x. So a to the power x by ln a. That is the integration of whatever we saw. So integration of x equal to 1 to infinity. If I was saying somewhere x equal to 0 to infinity, actually it will be x equal to 1 to infinity because I is 1 to infinity. So it will be x integration x equal to 1 to infinity. A is 1 by 2. 1 by 2 to the power x divided by ln 1 by 2. Okay. Now limit is 1 to infinity. If I place infinity, then 1 by 2 to the power infinity will be 0. So first is 0 minus, and then 1 by 2 to the power 1, that is 1 by 2 by ln 1 by 2. Minus is outside. Ln 1 by 2 will be ln 1 minus ln 2. Ln 1 is 0 minus minus plus 1 by 2 into 1 by ln 2. Ln 2 is around, I believe, 0.7. Ln 1 by 2, 1 by 2, ln 2 is 0.7. 1 by 0.7, 1 by 0.7, if it goes up, it will become 1.4, I believe. 1 by 0.7, that will be 7, 10 by 7, that will become 1.4, 1.43, 1.43. Okay, 1 by 1.43 by 2. Hop. Okay, it becomes 1 by 2 into 0.7. It becomes 1 by 1.43. Oh, I'm sorry, 1 by 1.4. Okay, this will become a Point 0.7, it will become zero point 0.7 and something. It is not 1 the way we expected. But anyway, this can be considered that we came close to solution. This is how we convert this is how we convert the repeated summation into integration. The repeated summation, the actual result is 1, where we are getting 0.71, something like that. Why this much disparity is there? Anyone will ask. Integration should be very perfect, right? Why this much disparity is there? Disparity is there. This much disparity is there. Integration work in a fashion when we have delta. When we divide our problem into n part, our problem is actually in n part, and that we are trying to solve into integration. Actually, the actual situation should be we should divide our problem into n parts. And then if I go by axis way, someone can take it as an assignment now. That how it will come to one anyway. Now the integration work in a fashion that if I have a graph function over x, this is function over x-axis, and this is x-axis. This is x-axis. This is function over x-axis. I have a curved line. If I have a curved line, then I have a curved line. Okay, how to get integration of a curved line, that is fx dx. Okay, it is similar manner. How I can get integration fx dx through repeated summation. Other way I'm talking. Then if I want to repeated summation, then I'll chop my x-axis into n part. Consider this is 0 to 1, 0 to 2, 0 to 3, some fixed number, not infinite the way we did in earlier example. 0 to alpha is the x-axis. Alpha can be 1, 2, 3, 4. Now I divide it into n part where n tends to infinity. In that fashion, if I take any of the part, now I have to take vertical bar from that is fx from any point only one time in one section. If there are n sections, then there are n number of vertical bar I have to take. Each bar will be multiplied with the delta x. That will become area of this strip, and that I have to add. Make sure the delta x tends to 0. That's why I took this example. Why solution is not coming? Anyone would jump. Boss, it is coming zero point 0.7. It is not 1. How integration is accurate? It is not accurate because we did a summation I equal to 1 to n tends to infinity fxi delta xi, where delta xi is 1. Delta xi tends to 0. Should be tends to 0. Then also we can bring into integral calculus because it is infinite, and 1 fxi delta xi is the area of one strip. Then add all the strip, it becomes fx dx. But delta xi tends to 0. We have delta xi full-fledged 1, very big. And that's how it is not accurate. Now some it is assignment that how really we can bring the solution through integral calculus, where delta x is not 1, delta xi should be 0, tends to 0. Okay, then we can take some limited length and then we chop into n part. Then we redefine our series. The series is 1 by 2 to the power x. We will redefine the series fx to bring gx and then gx dx, and then it should give the solution. How to redefine it? Now it is up to the person how he thinks about it. It can be taken as assignment. What's going on? Okay, if I have fx the way we are saying, if this is if this is x-axis and this is y-axis of function over x-axis, and this is fx. If this is fx, okay, consider fx till here only. Discard this portion. So this is fx. This is fx means when x equal to 1, then height is 1 by 2, then 1 by 4, 1 by 8, 1 by 16, 1 by 32. In that fashion, if that is the case, then we are trying to get first first value. If I say, if what is the summation? Summation is I equal to 1 to n tends to infinity fx. At x equal to 1, I have 1 by 2 into 1. This is 1 or this is 1, whatever it is. I believe this is what we are taking. This is 1 into 1. This is the area strip we are taking. Then we are taking another area strip. That height is 1 by 4 into 1. Height is 1 by 8 into 1. Height is 1 by 16 into 1. This is how our repeated summation is working. Summation I equal to 1 to n function over x delta xi, where delta xi is 1. In that fashion, first we are taking this rectangle as the area. What is a rectangular area? That is 1 by 2 into 1. This is the rectangular area. Function over xi into 1. Then function over xi into 1. Okay, this is more or less like a staircase. This is the height is 1 by 2 and there is a staircase like a rectangular region. We are calculating the area, then we are coming down to next stair 1 by 4 into 1. Then coming down to next stair 1 by 8 into 1. Then coming down to next stair 1 by 16 into 1. So rectangle by rectangle, we are adding the area and then it becomes 1. But if I go to integral calculus, then fx we have taken is 1 by 2 to the power x. Okay, if I take in that fashion, then we are taking the first area now. First area is fx is what is the graph actually? If someone does graph, then in integral calculus, graph will be continuous graph. Graph will not be discrete graph. It will be continuous graph. So at x equal to 1, its height is 1, then 4, then 1 by 8, 1 by 4, 1 by 8, 1 by 16. Graph will come continuous like this. It will not come like a staircase, the way we did in the repeated summation. Then it came as a staircase, dip, 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 dip. Someone will climb down like a someone climbing down in a staircase. Here it is a continuous line. If it is a continuous line, then first section area is height. This is the height, and next height is this. It is more or less. It will be more near if someone takes the average height of the I equal to 1 and I equal to 2 and multiply by the width. More or less, it will come to that means repeated I equal to 1 to n tends to infinity. 1 by 2, 1 by 2, 1 by 2, 1 by 2 minus 1 by 2 plus next one, that is 1 by 4 by 2 to the power x, something like that. Someone has to take the middle portion. But here in integration, we are taking area addition of this area where line is like this, line is coming like this. So this area of the first section, if you see, then this is 1 by 2, another line is 1 by 4. If I take a straight line also, then it will form like a slope. One side is 1 by 4 and one side is 1 by 2. But if I take in repeated summation, one side is 1 by 2, then other side is also 1 by 2, this area. Okay, whatever the missing portion we are seeing, that is missing in the result. Someone can try. What is the area, first section area in repeated summation? 1 by 2 into 1. Area is 1 by 2. If I take a straight line also in the integration, then one side is 1 by 2. Another side is 1 by 4. If I take a straight line, then what is the area of this section? This will be 1 by 4 into 1. Okay, this will be 1. This is 1 by 2 and this is 1 by 4. If this section area will be 1 by 4 and then this will be a triangle. Triangle means it is in 1. This is 1 by 4. Okay, the area will be 1 into 1 by 4 into 1 by 2. That will become 1 by 8. Okay, this area is 1 by 2, 1 by 4. This is 1 by 8. 1 by 4 plus 1 by 8. How much it will come? That will come as 8 to 3 by 8. The area of the first section of width 1 is 3 by 8, whereas there it was 1 by 2. Okay, 3 by 8 is less than 1 by 2. Makes sense? How much it is less? Okay, let's multiply both by 2. Or 1 by 2 is 0.5 and 3 by 8. 3 by 8 will be, I believe, it will come as 3 by 8. Or if I double it, it becomes 1. And that if I double it, it will become 6 by 8. 6 by 8 will come as how much it is? 0.7 and something. Same thing. If I take 6 by 8, it will be zero point 0.7 something, and here it will be 1. Similarly, the result of that is 1, and here zero point 0.7 something. That is the missing we are doing. How we can avoid this missing? This missing can be avoided only when the width is not 1. Width, the delta xi we are taking, width is tends to 0. If it is extremely small, then you take first. I took a rectangle in the repeated summation where we took a rectangle up till half only and then a triangle in the integration, and there it made difference, and exactly it made difference up till there only. Okay, that if I take very small, infinitesimally small beyond imagination, then it will come as rectangle only. Both sides it will come as rectangle only. Then it would solve the problem. Someone can try this. Do you have another example? Yes, certainly. Another example can be that consider I have many times I have talked about it. Consider I have a stick of length 1. Consider I have a stick of length 1. Okay, now I can cut the stick at any position. I can cut the stick at any position. I have a stick of length 1. This can be of length alpha also. For simplicity, I am saying 1. Alpha, but fixed, not infinite, the way we did. If I have a stick of length 1, then I cut at any position. Okay, I cut at any position. I take the begin part, this part. Okay, then I take the stick again, means I throw it, and I'm sorry, I'll repeat it again. I have a set of stick of length 1. I pick one stick, cut at any position randomly, and then I took the first part, keep it, and other part throw it. Like that, you take all the stick and cut it. Now, whatever I have stored now, measure the length of all the stick and tell me the average length. That is the question. Tell me the average length. Now, to solve this, now we divide this stick into n parts. If I divide this into n part, make sure that if we cut, then it will go exactly in one of the part. So I can cut it in only in n different sections, not in infinite section the way we thought about it. So I place a cut, and it will fall in one of the n section if I divide into n part. Okay. Now question is arising that what is the probability that I make a cut in a particular part. If there are n sections, then probability of making a cut in a particular part is 1 by n. Makes sense? If it is 1 by n and consider this distance is x, probability is 1 by n and this distance is x, then the average is summation of I equal to 1 to n x of the ith section into the probability 1 by n. Make sense? Oh, I did not understand how it is. I have given many times example of students. Like there is a class, and in that class there are 20 students. And this is a consider that students are getting marks. Consider that students are getting marks in kind of 1 to 10. 1 to 10. I would have taken a stick length as 10 only. Okay, consider that the students are getting marks in 1 to 10. There are 20 students. Okay, in that fashion, the student who get marks 5, students are getting marks in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, not 1.1 and 5.5, not in that fashion. Consider in that way. Now, please watch our previous video. Now, in that section, if I take 5, then 10 students have got 5 marks. 6 students have got 6 marks. One student has got 7 marks. That will come as 17. Two students have got 10 marks. One student has got 4 marks. One student has got 4 marks. 10 student has got 5 marks. 6 student has got 6 marks. One student has got 7 marks. And 2 students have got 10 marks. 2 plus 1, 3 plus 6, 6, 6, 9 plus 10, 19, 1. 20 students are there. What is the average mark? Then how many, if I take 4 marks, then how many students have got 4 marks? 1 by 20, that is probability. If one student is getting, then one student out of 20 students, the probability is 1 by 20. 4 into 1 by 20 plus 5 into 10 by 20 plus 6 into 6 by 20 plus 7 into 1 by 20 plus 10 into 2 by 20. If I add, I get the average mark. Makes sense? Similarly, here also, if I take probability of any section, that is 1 by n. If I had taken length as 10, the way we did there, then probability of one section hitting one section is is 10 by n. The length is 10. What is the probability of hitting at a particular point? If there are, I'm sorry, if there are 10 sections, and then if I made 10 sections of any length, what is probability of hitting in one section? 1 by 10, not 10 by 10. Means if I have made n sections, the probability of hitting in one section is 1 by n. Now this length into probability means if I say this is x, then x into 1 by n. Makes sense? If this is 1, then 1 into 1 by n. All probability is 1 by n only. Then 2 into 1 by n. Then 3 into 1 by n. Then 4 into 1 by n. Is it like summation I equal to 1 to n x of the ith section 1 by ith section 1 by n? I can rewrite what is the average length of the stick. If I cut a stick in any of the n section and then take the first section and keep it. Take another stick, cut it in any of the n sections, take the first part and keep it. Now take out all the stick. What is the average length of the stick? If I calculate the average length of, try to calculate average length of the stick, if I try to calculate average length of the stick, then what if I take the first section? If I take the first section, then what is the probability of the cutting it here, first section? That is 1 by n. Okay, then plus 2 into 1 by n plus 3 into 1 by n plus 4 into it is similar to summation I equal to 1 to n x, the distance of the ith section into 1 by n. It will come at x into 1 by n. Okay, if that is the case, x into 1 by n summation, someone can try. Can we make it integral calculus? If I want to make into integral calculus, then it is x into 1 by n. It is x into 1 by n, summation I equal to 1 to n. If I want integral calculus, n must tends to infinity, then summation I equal to 1 to infinity, n tends to infinity, x, and this height is called fx, that is 1 by n, x into fx altogether. But I want to convert it into integral calculus, then I have this graph as 1 by n, that is fixed 1 by n, that is fixed 1 by n. Okay, now if I want to convert integral calculus, this should be this this. I'm sorry. If I How I can convert it to integral calculus? What is summation? Summation is I equal to 1 to n tends to infinity, x into fx. Okay, if I want integral calculus, it will come as integration of x equal to begin to end gx dx in that form. Okay, dx is nothing but if I have x-axis and gx is a graph, then underneath area is gx dx. But here, if I am seeing here, there is nothing called I have x into fx. More or less, if I keep out, it is fx. Fx is the height, that is 1 by n. But multiply by width is missing there. If I multiply by width was there, then directly I could have taken as integral calculus. How to bring multiplied by dx, multiplied by the width, that is 1 by n. Okay, someone would say rewrite it. 1 by n is fx, right? That is same as 1 into 1 by n. 1 by n is the width you want. Yeah, I want 1 by n is the width. If 1 by n width you want, then it is 1 into 1 by n. Then 1 is gx. If fx is 1 by n, then it can be rewritten as 1 into 1 by n. When 1 is fx and gx and 1 by n is delta x, width and height. Now you can convert into integral calculus. Yes. Then now we can do x into gx dx. X is from 0 to 1. Now gx is 1, x dx, x squared by 2, 1 by 2. 1 by 2 is the average length of the stick. This is the actual form of summation to integral calculus. Okay, person can see more in it that we have already discussed. If there is summation of fx and I want in integral calculus will be in form of gx dx, means fx equal to gx dx. If I want gx, then gx equal to dfx by dx. Okay, anyway, that is the kind of, we will proceed on this because if this is extremely difficult and extremely miniature to understand. It is not that straightforward the way it looks. Anyway, we will talk more on it, and this explanation and example probably you will not find at many places. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone.